Hello everyone and welcome back. I am Mr. Cobalt, and in this video I'm going to start to get into this idea of combustion analysis and how you can use that to find the empirical and molecular formulas in different problems. And so the thing with combustion analysis is that as the name suggests, you're combusting something or you're burning it. So you have a substance that's burned, and they give you a certain amount of that substance that's burned. So maybe it's 5 grams, maybe it's 0.5 grams, but they say, okay, you have this amount and you burn it. And then when you burn something, especially if there's carbon and hydrogen in the substance, you're going to get carbon dioxide and water. And so the way the problem works is they give you a certain amount, they say, okay, it's burned, and then they give you a certain amount of the carbon dioxide that's formed and the water that's formed. And if there's a nitrogen in the substance, they may give you a certain amount of nitrogen product, and that's going to depend on the problem itself. But most of the problems, they don't really include nitrogen. Most of the problems are going to be including carbon dioxide and water because they are carbon and hydrogen based, or hydrocarbons. What they'll tell you in the problem is that it has carbon, hydrogen, and oxygen in the problem, or in the compound. You burn the compound, all of the carbon in the compound goes to carbon dioxide, and all the hydrogen in the compound goes to water. And then if you've got nitrogen, the expectation is that the nitrogen all goes into some nitrogen based compound. So with that in mind, you can then use the information they give you, the grams. If they give you, there will usually be grams, they'll give you a gram amount of that substance, right? So if they give you grams, then what you'll need to do is, since if you want to find the empirical and molecular formula, you need to get the moles of the elements, right? That's your goal in these problems, is to go from what they give you and to get to the moles of the elements, right? So if you keep that in mind, it makes it easier to focus on what you are doing and what you need to do, right? So they're going to give you some gram amounts. So they'll give you grams of this, or grams of water and carbon dioxide, or grams of whatever substance. They'll give you grams. The first thing you're going to want to do is convert the grams of these products to moles, right? So you want to convert these to moles using the molar mass. So MM for molar mass, molar mass, molar mass, molar mass. So you're going to use molar mass of the products and convert that to moles. So you're going to get moles of CO2 and moles of H2O and moles of whatever this product might be here, right? And then once you've got moles, now you can go to step 3, which is you're going to convert the moles of the products to moles of the elements, right? Carbon, hydrogen, and nitrogen if you've got something with nitrogen in it, using the mole ratio in the formula, right? So since you know that in water to hydrogen ratio, 1 water molecule has 2. So the mole ratio would be 1 to 2. 1 to 2 for the hydrogen. And so you would use that to convert from water, the moles of water, to moles of hydrogen, which is what you want, because remember, all of the hydrogen goes into the water, so you want to get to the moles of hydrogen. Once you get to the moles of hydrogen, you want to box that number, because you're going to use that in your empirical formula, right? Your pseudo-empirical formula when you find it, right? Same thing with the carbon. So as soon as you convert carbon dioxide from grams to moles, and then you use the 1-to-1 ratio to convert from moles of carbon dioxide to moles of carbon, you're going to circle that and then save that for later, right? Okay, so once you get the moles of the carbon, hydrogen, and nitrogen, if you've got nitrogen, you're going to then convert those to grams. So you need the gram amounts of these elements, right? And the reason for that is because your problem is going to have oxygen in it. Your formula, your compound is going to have oxygen in it as part of the formula, and so you need to find the amount of carbon, the amount of oxygen. Now you might ask, well, why can't we just use the oxygen here, right? So why can't we just do the same thing and find out the moles of oxygen we have from the compound? Well, the reason is if you remember or understand when you burn something or when you're combusting something, if you have something with hydrogen, carbon, hydrogen, oxygen in it, and you burn it, you are burning it in the presence of oxygen. That's how you burn something. You can't burn something without oxygen. So what happens when you burn it, you're adding oxygen. So some of the oxygen from the atmosphere is going in to make your products, H2O, CO2, and so on. So that oxygen, some of that oxygen did not come from the original substance. Some of it came from the air around when you're burning it. So that's why you can't take the oxygen here and assume that all of that oxygen came from your compound. That's why what you need to do is you find the gram amounts of the carbon and the hydrogen that came from the product, because all of the hydrogen and carbon came from the product, right? So if you know the gram amounts of the carbon and hydrogen, then you can subtract that gram amount from the original amount that you're given, and then that gram amount is going to be the oxygen that's in your compound. Whatever's left over in the mass, when you subtract out carbon and hydrogen or nitrogen, whatever's left over, that mass has to be the oxygen. So you found the mass of the oxygen. So then you're going to subtract the gram amounts, you're going to find the grams of oxygen. And then once you find the grams of oxygen, you're going to convert the grams of oxygen to moles. So then you found the moles of your oxygen. So then that would be the last step, right? Because you found the moles of your carbon and hydrogen and maybe nitrogen if it's in the problem. And then the last step is to find the moles of oxygen. Once you find the moles of oxygen, you've got moles of every element in your compound. And so now you can continue with the problem as we did before. You set up your pseudo formula, you divide by the lowest number of moles, you get a ratio, you make sure that the ratio is all whole numbers. If not, then you'll have to multiply by some factor, and so on. So if you've got a combustion analysis problem, all of this up to step 6 is going to be new, right? So these are the steps that I would follow when you're doing a combustion analysis problem, and then go from there. So, and then you can identify a combustion analysis problem by the fact that if they tell you, hey, here's a substance, here are the elements in the substance, and we burn it. And then these are the products, carbon dioxide, water, whatever, and then they give you the mass amounts. That's a combustion analysis problem, especially if they give you that information and they ask, what's the empirical formula? Or what's the molecular formula? So I hope this is helpful. In the next couple of videos, I'll go over a couple of examples of combustion analysis problems, and I will walk through the steps, showing you step by step what to do. I hope this was helpful, and if you like this video, like it, share it, subscribe to the channel, make a comment in the comment section, and ring the bell for notifications. So that way if I put out more videos, or when I do put out more videos, you'll be notified. Thank you for joining me, and I'll see you next time.